Hello everyone. In this video, we're going to talk about writing a function rule. So you can write a rule for a function by analyzing a table of values. And I've got several examples for this video, so we'll work them all out together. We're going to look for a pattern relating the independent variables, or x, and the dependent variables, the y values. And sometimes I'll have f of x over here just for the more formality aspect of y equals. But again, generally f of x and y are the same thing. It's just if you're dealing with more than one function, you may be given f of x. But here's what we do to write a function rule. We ask ourselves, what can I do to 1 to get 5? What can I do to 2 to get 6? And so forth and so on. It looks like here I'm adding 4, and it looks like I'm adding 4 to all those values. So it's safe to say that a rule for this function is f of x equals x plus 4. Because what do we do to x to get f of x? We're adding 4 to each of those values. Let's do another example. Here I've got x and y. What's different about this one, and I will say this as a general note, some functions have graphs that are not straight lines. And we can graph a function as long as we know its rule. So after we've graphed the ordered pairs that we have, once we've calculated from the rule, we can join the points together with a smooth line or a curve or however the points will fit. If you want to plot these, that's entirely up to you. But generally, for finding the function rule, you don't have to. But here's what we want to ask ourselves about this function. How do I get to 1 from 1? How do I get to 9 from 3? So forth and so on. Generally, from 1 and 0, those are usually the two best numbers to work with. And if you happen to have those values in your table, it's a good stepping stone for figuring out that function rule. Well, here it doesn't look like I add anything. Here from 3 to 9, well, I multiply by 3. I don't multiply 3 to 1 to get 1, so that rules that out. 3 times 3 is 9. That works. Likewise, 6 times 6 is 36, and 9 times 9 is 81. So for this function rule, what I'm doing is I'm multiplying x by itself, or more specifically, y equals x squared. This is a curve, and we'll talk about curves much later on in algebra, but for right now, this is just the general idea for a curve. Let's take a look at another one. Here I have f of x and x. How do I get to -1 from 1? How do I get to 0 from 2? So forth and so on. It looks like I'm just subtracting a value of 2 for each of these. So here I can say f of x equals x minus 2. Because I'm taking away 2 from x to get f of x. Let's work out one more. Here I've got x and y again. Table of values from x ranging from 1 to 4. Here I've got y that appears to be doubling in value as this goes up by 1. These are being doubled, so 1 times 2, 2 times 2, 3 times 2, 4 times 2, and then so forth and so on. It's safe to say that for this function rule, we can say y equals 2x. Double your x value to get your y value, and there's your function rule. Thank you so much for watching, and I will see you later.